Hello students, welcome to today's session. So today we shall be taking up one doubt of Zeise salt. This is a doubt which is being sent by somebody from South, and I thought of placing one video on this because I received it yesterday. So I find it this question is quite an interesting one and a challenging one. The question is containing more than one choice type of a problem. It is that in the Zeise salt, what may be correctly said. So the question is talking about central metal cation to form acting as a pi donor or sigma acceptor, and ethene is acting as a sigma donor or pi star acceptor or something like that. In terms of the bonding, it is being asked. So while solving this problem, I will be telling you few more things which is very interesting, you would feel thrilled with. So this particular platinum is placed in the D block in placed in the periodic table in D block, and it is below the platinum nickel. And here you should also add to your knowledge bank that nickel is argon 18 3d8 4s2. Now this also is very interesting to tell you that this particular group, the all the three elements are showing a ambiguous configuration. So as regard to platinum, it is 4d10 and there is no electron in 4s, and for that, as in regard to platinum, it is 5d9 4s1. So this is ambiguity in this particular group. Only the nickel is behaving the way it has to show the configuration. So this is one thing which you should add to your knowledge bank. Now as regard to the Zeise salt, if I talk of its preparation, that how do we get this in lab, basically this complex, very popular and stable complex of platinum, that is platinum tetrachloro platinate, it is being the ethene gas is passed through it and resulting in the ligand exchange. So it happens to go this way, that ethene takes the position of one of the chlorine and throws out one chloride ion out of it. So potassium chloride goes out. So this is the way it is being generated. Now as regard to the bonding aspect, if I would say that in this complex the platinum is making a square planar complex, and this square planar complex, the platinum which is in plus 2 oxidation state is using dsp2 hybrid orbit orbitals, or dsp2 type of a hybridization. If I write platinum in plus 2 oxidation state, these two are the electrons which would go out, one from the 4s, another from the 5d9. So two electrons would go out and resulting in 5d8. And this 5d8 electrons, if I would place it like this, 1 2 3 4 5 6 7 8. Now as and when the complex is being formed from the ethene, which tend to form uh, uh, p, p pi d pi type of a back bonding, as we will see into it, that here what you are able to see that there is happening the pairing. So once this pairing has happened, so what you are left with is this sort of a arrangement, that you would be all the electrons got placed here, and now you would be having the availability of three orbitals which you should require. These are the three orbitals which we shall be requiring for making the bond. So here comes the two electrons of chlorine, chlorine, chlorine and chlorine. And here what you would see that this is the dsp2 hybrid orbital, dsp2 hybrid orbital of what, platinum 2 positive, which is going to receive electron density from ethene. And which electron density it is going to receive and how is it going to receive, we are going to discuss in a while. So what exactly is to be done? So because since this engages something in relate to ethene, so first I have to tell you how the ethene is being bonded. So this particular 5 bonds, I have shown it for the sigma bonds, and this is what you call it as ethene making a pi bond. And this pi bond which we have shown would look like a this would be said as pi molecular orbital, bonding molecular orbital of this. I would write it once again, this is pi bonding molecular orbital of ethene. And here you have all the sigma bonds the way it is being shown. And also you should remember that this ethene would also have a pi star molecular orbital, pi star, that is anti-bonding molecular orbital, pi star anti-bonding molecular orbital, which is, now this is containing the electron density, this is containing the electron density, but the pi star anti-bonding molecular orbital of ethene, this is vacant. This is still vacant. Did you get this point? So this is in regard to molecular orbital theory. Now, what exactly is happening here is that this is what I have shown is dsp2 hybrid, dsp2 hybrid orbital of platinum 2 positive, which is vacant, this is vacant orbital. And this vacant orbital, whereas ethene has filled electron density. Now this is very interesting to tell you, this is the filled electron density of pi bonding molecular orbital is filled with electrons, and this is of ethene, filled electron density of ethene. Now what exactly do it make here is this electron density goes to it. Now, how do we count for this? How do we announce this? What type of a bond we have generated? We will be saying that who is receiving platinum 2 positive is receiving electron density through. This would be said as to be, this is very important to explain it here. We will say this as to be sigma bond, and this sigma bond is between platinum 2 positives dsp2 hybrid orbital, which is a accepting orbital, which is accepting this pi electron density of ethene, but into which orbital? We will be saying hybrid orbital. So this hybrid orbital is receiving the electron density, so we will be saying that dsp2 is sigma acceptor orbital, and who is donating it? The donation is being given by, this donation as I have written is donation is being given by pi bonding molecular orbital of ethene, would be said as the donor orbital. So ethene is donating its electron density through the pi electron density goes to what? Hybrid orbital of platinum, making a sigma bond. This is where the confusion is. Generally people take it as to be pi, but I would say this is a sigma type of a bond where the electron density which is being received is by hybrid dsp2 orbital, which is receiving the pi electron density. Now see here, now what else would happen? Now this is the, now as we have seen that in the in while evaluating the hybridization, so these all get filled up, this filled electron density of what? Of platinum 2 positive in d subshell, or d orbitals are being filled because of the back bonding. So one of the filled d orbital, now what would it do? So this is filled d orbital of platinum 2 positive, which is going to do the sideways overlap with which orbital? These are the pi star anti-bonding molecular orbitals of ethene, which in a way are vacant. So these are vacant. So what it is happening? So here platinum is giving back, so platinum's 2 positive orbital, which orbital? d pi, or you would say this is the d orbital is giving back the electron density. So here d orbital is pi donor, and that is of platinum. And who is receiving it? Receiver is, or acceptor is pi star orbital of ethene. So this is very interesting to tell you. Now let us go back to the question we are almost done with. So what is being asked here? Then I will tell you a few more things. So central, so what we have said, that platinum as a platinum 2 positive as a acceptor, if I would talk of acceptor, it is going to accept. So we will be saying sigma acceptor. And when it is donating electron density, it is donating electron density with one of its filled d orbital sideways overlapping with pi star molecular orbital of ethene. So it is pi donor. On the contrary, if I talk of ethene is donating, it is donating pi electron density, It is pi donor because it is giving electron density, pi electron density of the type bonding molecular orbital, to the vacant dsp2 hybrid orbital of platinum. And in terms of accepting, it is accepting electron density back into its pi star anti-bonding molecular orbital. So the acceptor orbital, we talk of pi star of the ethene, and the acceptor of platinum is sigma, which is a bit of confusion to a child. So if I will talk of the options available, central metal cation is pi donor. Yes, it is pi donor. This statement is right. And sigma acceptor. So this is correct. So A option is correct. Ethene acts as a pi donor. Is it a pi donor? Yes, it is pi donor. And pi star acceptor. So this option is also correct. Central metal cation is sigma donor. No, it is not sigma donor. It is pi donor. And ethene is sigma donor. No, this also is a wrong statement. So these two are wrong options. So the answer to this question happens to be A and B. This is very important question. Now how it can further be endorsed, that if you happen to see that in this structure, if I would draw it here once for you, that the structure of this would generally be shown like scale planar, like this. This is a scale planar complex where this is being shown like this. Is it okay? So this is the best way to endorse the other viewpoint. So let me show it in other way around. If I would show it like this is Cl, 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 and this is what you call it as ethene. So another beautiful question which has been asked way back in JEE mains type of a paper, that how many sigma bonds it would be having. 1, 2, 3, 4. This is the 4 sigma bond. 5, 6, 7, 8, and this is the ninth one. So this pi electron density, although this is giving its pi electron density, but to what? Vacant dsp2 hybrid orbital of platinum, which is the receiver, and that receiver is in the hybrid orbital. We treat it as to be sigma bond. So the 9 sigma bonds are there in this. 9 sigma bond is there in this. And what type of bonding other than that it is showing? It is also showing d pi back bonding. And this d pi back bonding is from metal. This is from the metal. And this pi actually is pi star anti-bonding molecular orbital of ethene. And this concept in a way also suggests you one more interesting question if I would create here, that this is another very important question which can be generated out of here, is the order of CC bond length in ethene in Zeise salt versus the ethene itself. So if I would talk that what would be the bond length of ethene in this complex, if I will talk in the complex, what is the bond length versus the ethene itself? So what do you think, what would be the answer? So we will say this CC bond length in Zeise salt becomes greater. Why is it become greater? Because of the two reasons. One, the pi bonding molecular orbital of ethene, gives electron density to dsp2 hybrid orbital of platinum. As a consequence of that, what does it do? It generates this pi bond in itself become weak, because the pi electron density, happen to go to the platinum, so resulting in a weaker CC pi bond. So if the pi bond get weakened, pi bond CC pi bond get weakened, and if it get weakened, so obviously this get weakened, so obviously the CC bond length increases. One reason is this, and second reason is also very obvious, that the pi star anti-bonding orbital is receiving the electron density back. So pi star anti-bonding orbital of Ce2H4 is receiving electron density from d orbital, filled d orbital of metal, filled d orbital of platinum 2 positive. So anywhere when this is quite again obvious, whenever anti-bonding orbital receives the electron density back, So the bond order decreases. So bond order decreases, that means the bond length is going to increase. So this is a very sure thing, that as and when anti-bonding orbitals start receiving the electrons that in a way is anti to bonding, so the bond order falls and bond length increases. So this is also very interesting, that in ethene's bond length, carbon carbon bond length of ethene in Zeise salt drastically decreases. Bond length drastically increases and pi bond weakens. So this is also very important. So I hope you have understood this particular uh, problem based on the Zeise salt. Hope you liked it, and if you have not yet subscribed to my channel, do subscribe, so that you could get the latest video at on time. So thanks a lot. Have a nice day. Stay safe and take good care of yourself. Bye bye.